so now in this video I decided to come back to this circuit, take some voltage measurements. Last video we looked at the current that is passing through the LED, the transistor, this resistor, that even if we change the supply voltage from 5 volts all the way up to 15 volts, the current going through the LED is about 10 milliamps of current. So it's going to drift a small amount, like 2 or 3 milliamps of current, but generally stays close to 10 milliamps of current. And now we'll zoom in and quickly review the schematic here. The main thing is this resistor here. So we set a voltage across here. It's probably going to be about 0.6 volts the way we have this set up, but it will drift a bit. Again, we're going to take voltage measurements later. So it's easy to set that voltage with this circuit. Once you got that voltage, that sets the current through the resistor. The power though is coming from the transistor, not the signal there. That's just, letting it know a voltage. And so the current's going to go through the transistor, and it has to go through the LED because they're in series right there. So once we have a voltage set here, it's going to set the current, but the current's going to go through this path. So everything is going to have about the same amount of current going that way. And so it'll be about 10 milliamps in this circuit. That's because, approximately, if we have 0.75 volts across 75 ohms, that would be 10 milliamps. So it's going to be approximate. But again, things don't work out perfectly in the circuit. With a couple of rectifier diodes in series there, each one of them is going to build up about 0.6 volts. We got about a 0.6 volt drop there. So we're going to build up about 0.6 volts times 2, again, approximate, for about 1.2 volts there. And so if we got 1.2 volts drop 0.6 volts, we'll have 0.6 volts left to go across the resistor. And so I need to get current going through the rectifier diodes, and actually they start conducting at a lower voltage. And so we're going to look at that today. So I need a somewhat significant amount of current. In fact, a lot more current would might even be needed to exceed the 0.6 volts. I could be wrong, but in any case, a 1,500 ohm resistor will probably start getting too hot above, somewhere probably around 15 volts right there. And so I don't want to go lower in resistance with this particular circuit. So I just paralleled a couple of them because I want more current, and thus I'll get twice the current there. Maybe I need even a third one for this to work better. I don't know. That's why I'm doing this circuit, just because it's an experiment, just to learn more myself, and also hopefully make an interesting video. But in any case, we got those two currents combined like it's a 750 ohm resistor. Right there will be the supply voltage minus about 0.2 volts across the resistors, setting the current. And thus, that current will also press on the LEDs until they conduct. And once they start conducting, the voltage will stop rising across them. Although, as more current goes through them, they start building up a little more voltage. And here is a close-up of the circuit. I moved this diode so hopefully you can see it better right there. But the gray band is there, headed towards the negative side. So these will be forward biased when we apply power, and the LED will be on there. You can see the resistor coming there for our reference voltage there. They're passing the current to get the reference voltage of the diodes. Base, the middle pin there. Emitter here, we got that resistor that sets the current. So it's important that we know the voltage across that. And, we know the resistor value because we pick that, although there will be a little bit of tolerance. And then, as I said before, we got this series path right there, where the resistor here, based on the voltage across it, the way we have this wired up as a current source, technically it's a current sink, but it's going to set a current. Pretty much, so we call it a current source. And the resistor is going to set the current based on the voltage across it. The voltage across it is set on the base there, although there is a diode drop that lowers that voltage that's set across it. And now we will zoom back and actually take the measurement. So with this meter, all I have to do is set it to V right there, and we're all set. The red probe I don't have to move for anything other than when I'm measuring high current. Right there, the power supply, so right now it's 5 volts, it's off, that's why the LED is off. This was actually, we got up to 30 milliamps of current in the last video, so I'm going to go to 40. So as I said before, the current through the LED is going to be about 10 milliamps of current, but we also, have current going through the resistors there that help set the voltage. and then thus that current's going to go through the LEDs there. So we're getting quite a bit more than 10 milliamps of current going through this part of the circuit when we get the power supply up to about 15 volts. And now we will turn the power supply on. You can see the LEDs lit up. We're close to like 10 milliamps of current right there, as we expect. The red LED is lit up. I think it's probably about 9 milliamps of current. I think we measured in the last video when we had 5 volts. I think it was a little bit more than 9. So in any case, we should get a pretty good idea what it is also by measuring the voltage across this resistor, 75 ohms. So there you can see it's actually about 0.7 volts. And so it's higher than I expected because of the low currents that we're using here. But that's something to be expected. 0.6 to 0.7 volt drop from base to emitter. And then each one of these building up 0.6, 0.7. You know, so let's see what we actually got. So it's actually between 1.3 and 1.4 right there. So a little bit more than the 0.6 that I estimated. But again, 0.6 was the minimum, as I said before. So I didn't take that into account when I drew the diagram. We can look at the single one right there. And of course, you know, it's probably somewhere about half of what the two are. They're probably not perfectly equal. So again, the rest of the voltage, we're dealing with 5 volts, goes across the resistors there. So that's going to be, you know, the supply voltage minus the drop of these basically, unless that threw it off for some reason. Total supply voltage, there we go, slightly less than 5. So that's what we're dealing with. We can also look at the, we can look at how much the LED is going to take off some of the power load from the transistor and the resistor right there out of the 5 volts. It's dropping about 2. So there's not much voltage. This is probably going to be building up about 2, the collector to emitter right there, a little bit more than 2 right there. And then we already looked at the resistor. So now let's look at the base to emitter, the voltage. So this will be the actual voltage drop. So again, closer to 0.7. So actually my diagram, I would have been better off if I used 0.7 volts for the how much the diodes are going to drop while forward bias and the base to emitter. But I think when I was doing this video earlier, I think when I was using a different resistor, it was like 0.6 and with a 1000 ohm resistor. So again, that's why it's important to take measurements so that you know what's actually going on with the circuit, not what is theoretically possible. And so now, of course, the point of this video, the current may have changed a little bit from touching components, as you can see there. So we're probably actually like 14 milliamps according to this. This isn't as accurate as a multimeter though. But if you're right on that edge, just a tad below like 14, it'll say 13, but then you bump it just a little more to 14. So it's actually 14, then it will change. Hopefully that makes sense. But in any case, the main thing about this circuit is we should maintain that current even as we raise the voltage. So you see current went way up. It's twice, but it should still be about the same through the LED. Almost all of that extra voltage should now be going through this part of the circuit. And transistor may conduct a little bit better because it's heating up a little bit more and whatnot. But the vast majority of that current is going through this part of the circuit. So that's just waste current. There's better ways to make a current source. This is more just kind of an educational what's going on. And when you see an inefficient circuit, you understand why the efficient ones are better. So now this is kind of interesting. We have about 0.8 volts across this. And I believe we had, you know, closer to 11 milliamps of current going through here. Whereas before it was like 9. So, you know, it went up like a little bit, but it didn't double, you know, like it should if you double the voltage when you have a circuit that just responds to voltage when it sets current. So yeah, it looks like, again, you know, it's about 0.7 volts across both of these, and then they add up to about 1.4. So yeah, we got, you know, about 1.4 volts total. And then, so let's see how much we're dropping, about 0.648. And so the rest of the voltage goes across that resistor. I think I'll do the math on the screen, but I'm not going to try to do it mentally. So again, we are dropping, you know, about 1.4 volts. So with these two resistors, remember they're both 1.5 kilo ohm resistors. So you got to pay attention to the wattage of each of them. Their wattages are independent, although they're close to each other. So they might kind of heat each other up a little bit more with the other one's heat. And again, we can check the total voltage here. and then the voltage across the LED plus the transistor. So again, we're 10 volts minus about 2 volts, and then that's what was that? Almost close to a volt. So what is that? I think like 9 volts left, or not 9 volts, 7 volts left right there across the transistor. Again, estimates right there. And finally, 15 volts. I'll try to go quicker this time. So we got, about 30 milliamps of current. I saw it go CCC in the last video briefly, so we're probably right on the verge of 30 milliamps of current, and easy to step it up just a tad so that it kicks in the constant current. But looks like 30 milliamps was still okay. Doesn't look like it messed up my last video at all. And again, so we can check like the supply voltage right there, the voltage we got across the resistor once I get a good connection. So we're closer to 0.9 volts right there. I think in the last video we were a little bit above 12 milliamps of current. So I'll try to do the math on the screen there. So let's look at that again. What was that, 0.8? Or almost 0.8 and a half, basically. But in case, not terribly great at mental math. Looked like now we're holding pretty steady with the signal voltage there. So if the voltage across the resistor went up a little bit, probably because the transistor's starting to conduct a little bit better as it heats up. So we can look at the split. We're still maintaining about 0.7 volts. So I think we're getting a pretty steady voltage with the diodes here and our 750 ohms resistors at like 10 volts and above. It was a little bit lower at the 5 volts, if I remember right. And again, so we got the supply voltage 15 volts minus, I can't remember exactly what it was, but that should be about the supply voltage minus the diode drops. Again, the base 2 emitter takes some current. In some cases, it may take a lot of current, so that could throw it off. But that resistor and, pretty easy current path collector 2 emitter should let the voltage that builds up across the resistor come almost exclusively from the supply voltage there. So as mentioned earlier, when I was first testing this out before I was making the video, I was using a 1000 ohm resistor. I don't think it was given enough current though, so I got a couple resistors here. So higher value, but together it's a lower resistance, an equivalent to 750 to get a little bit more current. So we're gonna see if some of the stuff I was saying was due to me thinking of when I was testing this with the 1000 ohm resistor. So power supply is off right now, but I want to point out I'm putting it to 10 volts now. I think we could go to 12 volts with this resistor, with how much the diodes are dropping voltage across it, where there's about 8 volts across it. I think it's getting relatively warm at that point there, close to 9 volts. 9 volts across it, actually, not 8. But in any case, in that range. We're not going to go over that too much. But now we got the 1000 ohm resistor, and let's see where we're at right there. It looks like, yeah, like 0.8 volts, which I think is what we should expect. Let's see how much we're building up here. About 1.4. So yeah, I think at 10 volts, this probably would work fine for like setting the current. But the main thing is, we want to be able to set the current at a relatively low voltage. That's why I'm using a couple of diodes here, because they don't drop a lot of voltage, so you can set a current at a lower voltage. If I use a Zener diode that should set the voltage to 5 volts across the resistor, of course we need at least 2 or 3 more volts more than that. And of course you can go higher, but that's like a minimum. So let's see where we're at here now. And yeah, it's still actually doing pretty good. So I think we may have been able to use a 1000 ohm resistor as long as we do not go to the 15 volts. Stay close to like 10, 12 volts right there. So yeah, that probably would have been okay, but for some reason it didn't work out when I was measuring before. So in any case, hope you still enjoyed. Again, this is about when you're learning about circuits, also test them. Listen to what people are telling you, but actually measure those voltages and stuff. That's also the skill you need to problem solve. Let's put the LED backwards. So the LED is not lighting up. We are wondering what is going wrong, and actually the LED doesn't want to plug in up there right now. So I may not be able to do this right away. Let's go to that one. Sometimes they just don't want to go into the breadboard. There we go. So I got the LED backwards right there, and there you can see we got some current flowing through, but we don't have an LED. One way to problem solve is first you want to make sure there's a voltage across the LED, and we can see that we got voltage across it. It should be lighting up. It's not going to be 0.2 volts because it's not dropping voltage, accepting whatever voltage is across it without conducting current. Now we turn around, now it's lit up. So that's one way you problem solve circuits and look for problems. If there's a voltage across a component, and it should be working with the voltage across it, the component might be inserted wrong. And so we will just settle with that example right there. So really long video. Thanks for sticking around this long. Check out the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.